Hello, everyone. I'm Adam here, and I was a part of the ground control project. And this was a mission control training platform. And our goal was to make satellite simulation accessible for everyone. Our team consisted of Austin, he was our full stack engineer, Cameron, Tessa on our back end, Daniel, who did the front end. I was on quality assurance, on Mohana did security. We had all of our bases covered for our team. There isn't really an accessible way to get into this for students or people who are, just looking for a free game. You either have to pay $40 on Steam to buy a game like Kerbal Space Program, which doesn't really give you any information on how to actually run the game. It's too complex for beginners. It's not really educational focused, and it does require you to install the game. It's over 50 gigabytes. Or on the flip side of that, it's over $200,000 per seat. It's professional only. You really have to be like a NASA scientist to run the thing. And we figured that we could find a median there. And that's where we came up with our solution, Ground Control. It's a browser-based training simulator that introduces users to satellite operations through interactive guided missions. So we have a virtual satellite, there's a simplified console, there's AI guidance to help you learn about satellites as well as help you with the game itself. There's structured missions that will blend learning with the game to help you understand what it would be like to operate a simulator. And then just a few of our core features there on the right as well. But really everything does kind of come back to that real-time simulator. And that's where we're going to show the demo.
Sweet, we're just going to dive in. We're not going to show you the authentication. We did use Firebase Auth and Google sign in and stuff for that. This is basically going to be your mission control, where as you can see we're on the missions tab. You can filter missions and stuff like that. Obviously for this we've only created one. This will take you to your mission briefing. We wanted to as close as possible match, like a NASA style, Starlink, whatever. This basically goes over your scenario steps, what you're going to be going through, the suggested duration and stuff like that. And then we added a gamification feature called MP, which stands for mission points. We just introduced that now, but we can add it for scalability later. And so this is where things kind of really get fun. So we introduced this little animation sequence where we're going to actually add real NASA T countdowns and stuff. We can get really fun with the audio here eventually and stuff like that. Then your satellite launches to orbit. So let's go ahead and bring up the scenario steps. So how like NASA and satellite controller systems work. Basically, you have to stage the command you want to accomplish, and then you have to commit it. And based on, security levels, sometimes if you're trying to do this with a satellite, you have to have your supervisor come in and put in their passcode or whatever. Let's just do a simple one here. So this, you look here, everything's under what it does. So let's just do a simple system ping, health ping. So you watch in here, you got your health ping staged, and then you have to commit it. That was a simple command. So you got the ACK, it acknowledged it, and then it sent the response. Nova is our AI. Let's go over Nova. You can ask Nova, who am I? And Nova will respond with your call sign, Top Gun Maverick. It'll tell me where I am, your mission progress. So you can ask it mission specific. It tells me, hey, you just completed step 3. You're on this next step. So now, anyway, so that's the AI. We've made it stay mission focused or whatever, especially when you're in the simulation. So I just want to briefly go over the 2D projection, and it supports simple latitude, longitude grids on equitangular projection. And then we can switch over to the 3D view. And we use 3.js. Oh, and the images used are the blue NASA marble. So it's true to scale, true to color images. And then you can follow the satellite. And as you can see, the satellite is moving really slow. This particular LEO satellite takes 93 minutes to circle the globe. So we added a feature where you can actually speed it up, and then you can see the movement a little bit better. And then we can go back to that 2D view. You can see the satellite's moving a little bit faster.
So to finish off, our tech stack for our front end, we did use React. Our backend, we used Node with Firebase. Our database, we used Firestore. And they were kind of, new to all of us, but we did learn them. And it was kind of, an interesting thing to now have that in our belt. For AI, we use Gemini. For QA, I, use Supertest for the back end. And then on the front end, I used Playwright tests. And then for security, that's kind of working with Mohana on our team to get those in place. And then what we learned as a team, kind of just that user feedback is critical. So early on, when people are using the app, that you have to have the users using it to know what's going on and what can be fixed.